Okay, in this video, I'm going to go over number 4 on Math 161, Pre-Calculus 1, Exam 1 practice problems. Number 4, let's take a look right here. Algebraically determine whether the following functions are even, odd, or neither. Now, remember we talked about how, well, I should probably do the bottom one first. Fill in the blank. Even functions are symmetric about the y-axis, right? And to be symmetric about the y-axis, for example, think about an even function, like y equals x squared. You have a nice parabola. If you plug in, say 2, then you're going to get 1, 2, 3, 4, right? You have a point at 2, 4. But if you plug in negative 2, what do you get? Negative 2 squared is still positive 4. So what you are seeing is that if you plug in positive 2, you get the same answer that you get from negative 2. That's what makes it symmetric about the y-axis. So instead of just 2, how about we generalize and say the function value for f of x, the value that you will get if you plug in x into the function will be the same if you plug in a negative of that. If this happens, then you have an even function. Then the graph will be symmetric about the y-axis. So remember how I talked to you, told you in class that if you get one of these problems, just plug in what? You're going to plug in negative x, okay? You're going to plug in negative x. And if you plug in negative x, that's what we're doing, right? If you plug in negative x and it comes out to be the same, exactly the same, then we're going to say that the function is an even function. So let me try that on A. Okay, let me try that on an A. It has to be exactly the same. So if I plug in negative x, negative 5 times negative x to the 4th power, and you know, seeing these even exponent even powers is a good start, because if you square or if you take 4th power, if you take any even power, negatives will all pair up and will turn into positive. All right, let's keep going though. Plug in negative x everywhere you see x, and then we're going to simplify the signs. Now take a look. What happened if you do negative 4 to the negative x to the 4th power? That will be positive x to the 4th power, right? Because if you multiply negative x 4 times, you know the sign rule. These two will turn into positive. These two turn into positive. So if you multiply them 4 times, you will get a positive answer. All right, keep going with the sign. Plus 2 times. Same thing over here. If you do negative x squared, that will be positive x squared. And, well, we have to be careful here. See, there's a negative times negative over here. That will turn into positive 4x. Let me go ahead and write down my final answer. Negative 5x to the 4th power plus 2x squared and plus 4x. Now, they have to be exactly the same. This, what I just got, has to be exact. I don't like gray color. How about blue? What I just got needs to be exactly the same as the original function to be called an even function. Now, let's see if they're exactly the same. It was negative 5x to the 4th, negative 5x to the 4th. The first one is the same. Positive 2x squared, positive 2x squared. That is good. But look, negative 4x, that changed to positive 4x. So, you know, this is not even function. This is not an even function. And in fact, this one is neither. I should have probably talked about, we did talk about what it means to be an odd function in class. To be an odd function, all signs must be opposite in sign. All terms must be opposite in sign. So say that if you get f of x equals, just making up an example over here, okay? Negative x to the 3rd power plus 5x squared, not squared, 5x to the 5th power minus x. Say that you have that. And then you found your f of negative x and you got positive x cubed minus 5x to the 5th and then plus x. Then if there's something like this happen, notice how all of the signs, negative to positive, positive to negative, negative to positive. If all the signs change just like this will be an odd function. But notice how the one that we just did together, 2 of them stay the same. The last one changed. So, you know, that's not good. That's just neither. That is not neither even or odd function. So again, I keep emphasizing, you need to plug in what? Negative x and show me, simplify all the signs and show me that it's either exactly the same or all opposite in signs. Let me try another one down here. It says, well, let's fill this blank in. And all functions are symmetric about the origin. So to make that true, what we need is f of negative x must be equal to negative f of x. Okay? In other words, you plug in negative x. If all the terms come out to be the opposite in sign, then that's when we can say it's an odd function. I don't know if b is an odd function, but let's try. Okay? I plug in negative x in here. 2 times negative x to the 5th power minus negative x plus 1 over negative x. Okay? Well, look at the signs now. What will that be? What I'm circling? That is negative. That's going to be negative. Why? Because 5 is an odd number. Whenever you have these odd powers, the negative x will stay negative. So I'm going to get negative 2x to the 5th power. Look at this. Not because of the signs, but it's, well, yeah, exactly. They're the signs. Negative, negative. They will turn into positive x. Now, look. You have a positive and negative. What's that going to be? Positive times negative is negative. So I can write the last one as minus 1 over x. So let's compare all the signs now. Used to be positive 5x squared. Positive 2x to the 5th. It's now a negative 2x to the 5th. It switched the sign. Check. It used to be negative x, now it's a positive x, yay! And the last one, it used to be plus 1 over x, now it is negative 1 over x. Notice all the signs are opposite in sign. If that happens, what do you get to say? This is an odd function. You can't just tell me it's either, even, neither, or odd without showing me this algebraic work, okay? So please show me the work on number 4 when you are doing this. I'm going to stop this video and then I will go over number 11 in another one, but just keep on the